demonstration on cloud performance engineering in DevOps. Okay. So my name is Roshan. Before we get started, let me introduce myself. So my name is Roshan. I am with Isha from last 4 years, associated with Isha. Uh, Overall, I have 16 years of IT experience. I have worked into multiple domains, started my career as a Java developer into development, and then I have moved into the automation part, the DevOps part. I have been doing DevOps using, I have been right now as a principal DevOps and SRE consultant with one of the retail giants of this world. And I have been into multiple cloud service providers. I have been the architect, associate architect professional. I have done the multiple certifications across multiple cloud. AWS being my favorite because I work most of the time, but it's not like that. I don't like Azure and GCP as well. So multiple, even OCI, Oracle Cloud Infrastructure. I worked with Oracle also for some point of time. Okay. Okay. So, and on my hobbies, I like to share my knowledge, and that's why we are meeting. I have associated with multiple institutes like Edureka, Intellipath, Simplilearn, and ESA as well, right? So on this cloud performance engineering SRE course with ESA. Okay, so that's a background about me, guys. So this is going to be the agenda for this session today. Okay, I would like to know before we get started about this audience. Okay, I believe most of us here are performance engineers, testers. Is that the right um, assumption or no? Could you just quickly confirm that, everybody?
So testers, a functional tester.
Okay, functional testers as well. Okay, good. Okay.
Yes, so Vishal this side, and just wanted to share one thing I am most of time I have spent on the automation testing side. I have some experience in performance testing, writing scripts and everything, right? Using
Right.
P6 and Jmeter tools, these tools.
Okay.
I have knowledge in cloud, AWS especially, multiple services there. I'm not sure. I was also evaluating the other courses of yours from the Isha, where there is one is performance engineering, right?
Right.
And I see this for the cloud performance engineering.
Cloud.
So,
Right.
so I am just trying to understand which would
We'll
be,
take up. I got it.
yeah.
I got a question. So you want to understand why this, what is difference between normal performance engineering and what is cloud? What are we going to talk about here in this course, right?
and
Is that
and even since what all topics this course is going through
correct? Correct.
since.
We'll do that. So let
Okay.
me. So Vishal, what I would say, if you could wait for everybody could wait for half an hour, right? I can brief from my side, right? And then I think your most of your queries would get resolved. Okay. And still, if you have doubt, we'll take up questions. Okay. So let's take this approach, going over one by one. Right now, it will waste a lot of time, people's time, because I know what I'm going to cover. So let me cover. Let me convey what I would like to do that first, and then we can open up for the Q&A and your queries. Okay. Okay. So I believe two people have responded. Can you guys quickly respond about your skill sets or which domain you're working on? Just one or two words, that would be enough. So I can see Gayatri is performance tester. Srija is into product testing. So I believe Srija, you're talking about functional testing, right? Product means the functional part, not the non-functional part, right, Srija?
Yeah, a functional and some part of non-functional as well, but
Okay.
mostly into functional and
Okay.
automation
Perfect.
testing.
Sure. Perfect. Good. Welcome. So you'll understand soon about this course, what it talks about this course, what value it brings to the table. We'll talk about that. Yeah. I would like to know from all of you. So I have got responses. I'm getting responses. So Sai Karthik is performance testing. Vamsi is performance testing. Debi Sankar is performance engineering. Prithvi is functional tester without P and PT. Okay. Piyush, performance tester with Jmeter. Ramesh, performance tester testing. Vijay and Santosh is 14 years of performance testing. ERP, okay. Performance testing, fresher. Okay, perfect, good. Thank you, guys. So it will help me plan the session better. Let me tell you about this agenda of this course first. So I would require like 40 minutes from my side. You'll understand why this course and what value it would bring to the table. You'll understand in next 40 minutes. So, okay. So this is the agenda. We'll start up with a question. Okay. We'll start this entire conversation about the course with a question, and then we'll talk about how in general how the software has been developed and deployed over the years. Okay, we'll talk about the evolution, and then we'll talk about the course, right? And then we'll take up your Q&A. Okay, that's the agenda for today's discussion. Okay, so this is the question. This is the question. So let's replace this word from performance engineers. Let's use anybody in IT. Okay, working in IT in the current market scenario. Do we think that DevOps, microservices, containers, and cloud are very much important to know what exactly are those from the DevOps, from the SDLC perspective, microservices from the application perspective, containers from the where do we deploy the applications, and then the cloud. Do we all agree that yes, it's mandatory thing, irrespective of your field, whether you are a functional testing tester or a performance tester into product testing, or you're starting your career as per the current market trend? Do we all agree that we need to know about this, about all these four technologies that we have mentioned?
Yes, sir.
Yep.
Right? Gayatri says yes. Yes, and a lot of other folks, yes. Srija says yes, right? Santosh says yes, and Vijay is saying yes. So now this is where this course talks about. Okay, we talk about the fundamentals that is required because I understand the pain point about the transition. See, when anybody starts in IT, and you would understand that why these four are important, irrespective of the skill, irrespective of the skill. And obviously, if you want to transition yourself, your career into performance engineering from the cloud, from the infra perspective, why this becomes the indispensable, the most important skill set to have. We will understand that in just some time. Okay. So let me put my next slide and you would understand why DevOps, microservices, containers, and cloud are important as per the current market trend. You will understand this when you understand this slide. When you understand the how the software has been developed and deployed over the years. See, software development started around 1980, right? In 80s, software development started like 50 years back, we're talking about. And the current market scenario that we are from the development process perspective, SDLC, software development lifecycle perspective, we have transitioned ourselves from waterfall, which had a lot of drawbacks and merits, to agile around 2000. And right now we are into DevOps. Like we are talking about DevOps. Everybody talk to anybody, they will talk about DevOps. We'll understand what is DevOps today in quite in a very high level understanding. We'll understand not about exactly automation, how we do it, but first of all, the understanding perspective, we'll understand that DevOps. Now, coming to the application architecture, when the software development started, it was all monolithic. And nowadays, it's all microservices. We are splitting the big monolithic code into various microservices, and it gives us more availability, reliability. It makes code, it's the management, the managing the code, it becomes simple, right? When you talk about the microservices. So we'll understand what is monolithic and microservices. Now, coming to the deployment part, where we deploy the application. So when we were developing monolithic applications, we were directly deploying on the physical servers or VMs, virtual machines that we call it EC2 instance. If you know about the cloud or virtual machines, node, virtual machines, nodes. We have multiple names. We call it VMs, nodes, instances, EC2 instances, whatever compute, VMs. So we deploy the monolithic application into VMs. Then why these containers? What is the main advantage of it? Which all companies are using these containers? Why are we deploying application in the container? What is the benefit? We'll talk about that. Now, coming to the cloud perspective. So if you, let's say back in 1980s, if you have a business idea, let's say like Amazon.com. Amazon.com, it's a retail website. We can use it to order so many products, right? So if you had a business idea back then in 1980, there was no other option but to set up your own data center, which was a very costly affair, very costly. You need to purchase the land, you need to construct the facility, building, right? You need to purchase all these hardware, you need to do the networking of it, you need to pay amount regularly for the maintenance, for the security of the infrastructure for the facility, a lot of cost involved. But now we have transitioned into cloud. Getting a server, getting a storage is not a big deal, right? If you just can pay a couple of $1,000 monthly bill and you can get it. The servers and storage is there for you. So we have transitioned. So we need to understand how it has been transitioned, and that's where this technology, the DevOps, microservices, containers, and cloud becomes so important, irrespective of the skill that you are. Even if you are a functional tester, you may be doing automation into Selenium, right? Or you're doing a functional testing or UFT, or you'll be using, but you have to understand what's happening, where the server is deployed. Is it in it? Maybe it's not required from a functional perspective where it is deployed and how it is deployed. You may not need to know that. You are mostly looking into the application perspective. If my application is functionally working or not. I understand that. But from a performance perspective, from the infrastructure perspective, it becomes so indispensable, so important to know that the infrastructure. And that's where this course fits, right? That's what we talk about this course. We talk about cloud. In this course, we talk about AWS, one of the largest market share. 40% of the market share is captured by AWS, followed by Azure and GCP. Azure is from Microsoft, GCP is from Google, AWS from Amazon, right? So we'll talk about AWS in this course. Now, what is containers first? We are talking about Docker and Kubernetes in this course, but before that, you need to understand the importance of it. Then only you would understand what is Docker and Kubernetes, right? Because everybody nowadays is talking about Docker and Kubernetes. You go and attend any interview, they will ask you, do you know containerization? Do you know what is container? How different it is from VM? Do you know Kubernetes? Are you getting such questions in the interview, my friends?
Yes.
Right? I think
100%, sir.
100%.
Yeah, that's
Santosh,
the reason. Like, I can't clear any interviews.
exactly, right? So that's where this, because I understand the pain point, the transition that happening, because see, no company would give you opportunity to learn. It's very difficult, right? But the companies, when they hire, they would expect you to know those things already. That is the bitter truth of IT. If you know stuff, you'll get hired. And we would do the same thing when we are the managers, right? Because we would like to recruit the best people, those who know stuff. It's easy to get onboarded. So that's the real truth, right? And that's where this course comes in. And we'll talk about these things in this course from the scratch. From scratch. When I say scratch, literally scratch. There is no prerequisite for you to attend this course, right? When we talk about AWS, it's from scratch. We'll talk about what is cloud, how different it is from on-prem, how do you create a server in cloud, how do you create a storage in cloud, how do you install an application in cloud, or let's say if you're installing it, if you want to install a Linux server, Jmeter, you can do that part. How do we do that first? What is server? So we'll understand that cloud from the AWS perspective, and everything is hands-on in this course, right? So I'll come to the containers part. Before I talk about Docker and Kubernetes about the course, let me explain the container part, why it is important. Now, why are we splitting monolithic into microservices? See, maintaining a big monolithic code is a problem. Even the smallest issue with one of the smallest function of one of the module can bring the entire application down. So it becomes important for you to split the big application into smaller modules so that they work independently. So that's the microservices. We'll talk about what is microservices, and obviously on the development process, what is waterfall, what are the problem, then we move to agile, what it is exactly it is agile, and what value we bring into DevOps, right? So we'll talk about this first. So we're going to spend next 15 minutes, right, about this particular slide, and then we'll talk about the course. Now let's start with the development process, waterfall. See, if you see, it's a basic IT, but anyway, I'm going to repeat that part, and you would understand from a different perspective. See, when the software development started, it was the first time anybody was thinking about a software development. So it was not the mature model, right? The mature SDLC model, it was not there, right? So what I'm going to do, okay, let me share one of the things with you. Okay, what I'm going to do. Let me just I'm going to one of my GitHub, because I have documentation already. So I'm going to just refer that, okay? I'm going to refer that so that it becomes easy for you to understand also. Just give me a minute. So what is SDLC? This is my GitHub page, okay, my repo. Okay. So when we talk about SDLC, what is the full form of SDLC? Okay, I hope everybody sees my GitHub. Yes.
Yes.
Okay, perfect. Now, when we talk about SDLC, before we talk about waterfall model and agile and DevOps, let's talk about SDLC. So SDLC stands for Software Development Lifecycle. How we go about developing a software. Let's take this example of Make My Trip. So Make My Trip owner is Deep Kalra. So see, right now we know Make My Trip, how it looks, right? But think about the Deep Kalra when he was thinking about a problem. See, for him it was a problem of ticket, how we book the tickets, flight tickets. Earlier, people used to go to airport to book the flight tickets. There was no unified platform where anybody can go and look, can get the view of all the options that they have, flights options, flight carrier options, the schedules, the timings. There was no unified place. So it's a problem. Even same thing for IRCTC, right? Earlier, I remember I used to go to a railway station to in my college days, right, and book tickets. Or we used to give some money to some agents, and they used to do on behalf of us. So it was there was, but now we have irctc.co. So every software development starts with a problem statement. Everybody wants to solve a problem. If you talk about Blinkit, Swiggy, or whatever the software Google Pay that we use, they solve a problem, and that's why they are important. WhatsApp, they solve a problem of messaging, right? How we talk in a group. Look at the teams here. Teams, we are connected to the teams here. We're able to do this conference call over the team. So for every solution, we start with the problem statement. And then let's talk about Deep Kalra. So Deep Kalra has this problem that he wanted to have a unified platform where anybody can go log in and book the flight tickets with so many options available. So let's say Deep Kalra approached any IT company, let's say TCS. I don't know what exactly TCS Infosys. I'm just taking a name of any software company, and then the software company would like to understand the requirements. Okay, Deepkanta, what is your requirement? What is your vision of this solution, this website? What are the features you're going to see in the home page? Okay, fine. The registration and the login. After that, a user would log in and get some this view. So requirement gathering. Requirement gathering could be functional, could be non-functional, right? All sorts of requirements. And then obviously the planning and designing will happen. The software will be planned and designed, the architecture, and then it will be given to the some development manager where developers would develop the application. So coding would start to happen. After coding, we will build the code. Let's say if it's a Java code, we'll build the code. When we say build the code, we mean about compiling, unit testing, packaging. Let's say we get jar file, war file, ER file. Then we need to deploy that. Deploy the artifacts to some QA environment for functional testing, performance testing, security testing, UAT testing, right? We can do that. Once everything is validated, let's call this phase as the quality validations phase, right? Quality validations. So once it is validated, obviously we can deploy the code to production. and then monitoring and feedback and so on. This process would keep on happening. That's the normal SDLC. But in what happened in waterfall, that the entire requirement gathering, whatever the requirement was there, we developed everything at once. Every code, every feature we developed, and then we started to test in waterfall. That was the approach. We have three approaches, SDLC models, we call it: waterfall, agile, and DevOps. So what did we do in waterfall? We developed the entire feature. First, we developed the entire feature, and then we started to test. What could go wrong? What major could go wrong in waterfall with this approach? Anybody?
Sorry, what's the question?
In waterfall, the approach, right? Approach is to develop every feature first. Every feature of the application develop, and then you start to test the application.
Requirement changes. If the any requirement gets, then it will be challenging to go back and start from scratch.
See, requirement, well, see, if we don't get one feature, I can go back and develop that feature. That's not what major could go wrong if you're not testing. Let's say we spent 1 year to develop the application, and for the entire 1 year, we did not even test. Obviously, the functional testing could fail. The application may not function as expected functionally. But think about the non-functional. Let's say the application is not scalable. The architecture, the application that you have is not scalable more than 100 user load. Now, can you go back and re-architect the entire architecture? Is it easy?
No.
So that was the problem, right, with the waterfall. Because see, somehow we started. That was the waterfall. Is it clear for all of you, waterfall? I want everybody to understand, participate in the discussion.
Yes, sir. Yeah.
Right?
Yes.
Right. So it was, that's what the and what did we do? We split the development. What did we do is we split into phases, into agile. So we went like, we will not develop everything at once and start to test. We'll go in phases by phases. We call those phases as sprints. You might have heard this word sprint. Phases. So we will develop one feature or set of features first. We will test it thoroughly, functional testing, performance testing, security testing. We'll go back to the customer, we'll get the feedback, and then we will incorporate those feedback and develop another set of feature. Again, we'll do testing, entire testing. We'll get the feedback from the customer. Again, we'll incorporate it. Then again, we'll develop certain set of feature. This process looks very much good, right? Perfectly fine. Yes or no? In Agile, do the feature wise, right, and do testing also. See, at the end, we will not get a surprise. Okay, what happened, right? In Agile, it's a good process to have, and still we use Agile. It's the most important way of development. Still, we are using it. Even those companies that are using microservices, still Agile process is being followed. But there was a problem with Agile also. See, things were done manually in Agile. See, now tell me one thing. If you have understood this discussion, when the code is ready, let's say when the developer is ready with the code, what is the main goal? What is the main goal? When the code is ready, what is the main goal?
Just test the
Deployment.
code as
Deployment.
possible.
Deployment where? Where to deploy?
Servers, local
Where,
host, or
which environment? Which environment? Production, right?
Report.
Yeah, server, that's obviously will deploy in a server. That's absolutely fine. But which environment? QA environment or a production environment? What is the main goal?
test
Go
the
live
production.
Deploy to production environment. See, all these are quality validations. We are just validating the code. Okay, it's working fine or not, functionally, performance wise, security wise, right? We are just validating the code. When the code is ready, this is my ultimate goal. So a lot of time was spent because things were done manually. When you look at this, when the code is ready and you take 1 month for the entire validation, It's going to be take so long and so slow. My customers would not get features, right? Think about, let's say you have issue with Flipkart. Right now you're observing any issue with Flipkart. Would you want that issue to be available next day at the earliest or not? Obviously, customer expects that. Any company, any website. Let's say if you have an issue with Blinkit, let's say you love this website and you see this issue, and that is you're bothering, or you're more expecting more from that. So there are a lot of softwares like Workday, right? We have Salesforce, like where client pays for the software. Right now we don't pay for Blinkit and all, we use it, right? We are the customers anyway. Because we order the products. But think about, because like the SaaS softwares like Workday, Salesforce, where clients pay the amount. I mean, obviously, the companies who builds those software has to make sure that the customers, the clients are happy, or whatever they're expecting, they're getting it. So we cannot afford to spend a lot of time in the quality validations, and that was happening in Agile because things were done manually. So what DevOps brought? DevOps talks about the automation. There is no problem with the approach, agile approach, but what should be done? The release velocity should be increased. And that can be only happen when we automate stuff. Let's say when the code is ready and you have some automation, we call it very popularly known as CI/CD pipeline. Okay, let's say you have the CI/CD pipeline, continuous integration and continuous deployment, and things get done automatically one after the another. Let's say you have a job for building the code. You have one job to deploy the code to a QA environment. You have one job to functionally automate and test the code. Let's say you have also done some Jmeter scripting and integrated that with Jenkins, which is a CI tool, and automatically the Jenkins job would trigger and it will run the performance test. It will do the comparison of from the last build, and if response time is less than 5% or 4% or 2%, it will give okay. If it is more than that, it will fail the job. So the pipeline would get failed and the developer would get notification that this job has failed, response time has degraded, error rates have increased. Please look into that. So if you have automation in this quality validation, in this entire testing and deployment phase, testing and deployment, we call it operations. All these testing and deployment, right? It comes under operations, development and operations. The entire IT software is divided into two categories: development or operation. Either you are a developer or you're into operations. If you are a tester or if you are in deployment, you are into operations. So think about it. If you can automate this entire process, do you think my release velocity would get increased? Yes or no? The customers, the clients would get the releases quite often. It's much. So if we bring in the automation, so do we think we can increase the release velocity, friends? We'll talk about how do we do that, but first acknowledge that part, that yes or no.
Yep.
Yeah.
Everybody
Yes.
agrees on that? Absolutely, right? That's how it happens. So we just bring in automation into picture, and that's what the DevOps. And that is why we talk about. So DevOps talks about SDLC, process automation, to increase the software release velocity. DevOps is coined from two words, development and operations. A better collaboration. So DevOps talks about better collaboration between the development team and operations team. Okay, and that's where this particular DevOps comes into picture, right? And nowadays, go to any company. Why this is important? Go to any company. You would be, if you are a functional tester or a performance tester or a security tester, you would be asked to work in the job, Jenkins job, so that things can get automatically triggered. Right? Yes, you prepare all the scripting part, all the validations part, but you will be asked to play an important role in the CI/CD pipeline because DevOps is at the organization level. So you need to understand what is DevOps. Let's say if you attend the interview and if let's say you don't know what is DevOps, then how the interviewer would feel that, okay, this guy even doesn't know what is DevOps, how he would, the person would, right? He or she, the person would be able to work. So we need to have that understanding. See, if you know Jmeter or a Selenium, it's fine. But how do you, what is DevOps? How these things gets integrated as part of CI/CD pipeline? That understanding is very important. That's the bridge we are talking about here in this course. Right. Now, that's the one part. Now, coming to this, what is monolithic? Monolithic is a big piece of code. Big piece of code. Again, I'm going to share one diagram. It's going to save a lot of time. If I draw that, it'll take a lot of time. So what I'm going to do, I'm going to just show you a second. Just give me a few seconds. Yeah, this part I was looking at. Now, I would like you to focus on this part. Okay, focus on this part. So what I'm showing you is a three-tier application, right? Web server, application server, and database server. Usually that's how we know, right? It's a most three-tier application, three-tier architecture. And let's say you are deploying things on the VM, virtual machine. Web server, where used to get the website, all the web pages that you see. Let's say you log into Flipkart. So all those pages that you see is coming from the web server. And then the logic, the application logic is written and deployed in the application server. And then we have the database where the product catalog information, the user details, the order details, whatever the details that you see in the website, they're all hosted in the database, right? So it's a three-tier application. I would like you to focus your attention on the application server to understand what is monolithic. So when I say monolithic, what exactly is this? So the entire code base, the application server is packaged together. It is packaged together. The entire code base is packaged together. Your all the modules, whatever the modules, the features that you have, it's all packaged together. When I say packaged together, what do I mean? What do we say? What do we mean by that? So let's say you have got let's say, for example, let's say you have got 4 modules. Could be inventory, could be your product catalog, right? Could be payments module, or could be any other modules. Think about any big application and you have some features. Those features, I'm calling it modules. M1, M2, M3, M4. For each of the features, you will write functions. Normally functions. Let's say you have written 20 functions for M1, 30 functions for M2, 20 functions for M3, 30 functions for M4. Let's say you have done that, right? These modules you have written the functions. In the monolithic, what happens? There is a huge dependency. You are calling F1 in, you're calling M1 in M2, M2, you're calling M2 in M3, you're calling M4 in across. So the functions are being called anywhere and everywhere. That's a huge dependency across the modules. And that's why they're packaged together. It's a big code packaged together. That's called monolithic. What is the problem? I'll tell you the problem. Since there's a huge dependency, the issue with one of the modules or one of the functions can bring the entire application down. It can bring the entire application down. That's the problem. Because there's a huge dependency. That's the problem. Huge dependency would create issue with one of the functions. Let's say there is some issue with F1. Since F1 is part of M1 and M1 is being called across all the other modules, so issue with one of the functions can bring the entire application down. And it's so difficult to manage this entire code base. Let's say you have made small change for a bug fix. Let's say you have done in F21 or in F51, let's say you have done a small bug fix. Now you have to build the entire code base to deploy that change. Entire code base. For small fixes, it becomes so difficult to deploy the entire code base, build and deploy the entire code base. It's not that easy, right? An issue with one of the functions can bring the entire application down. So how to solve that problem? Solving the problem is splitting the code. Split the codes. Split the code. Don't have that dependency. Be independent. So split the code. So this is what I'm talking about. Split M1, M2, M3, M4. Split it. Don't call the function directly. Create M1 separately, M2 separately. Here we're packaging all the code base at once. We are getting one jar file. When we package it together, we're getting one jar file where we have the entire code base. So when we say split, what I'm talking about, we'll get four independent jar files. Now, if I am fixing something in M1, only M1 code would get built and deployed. If I'm fixing something in F22, only the F22 M1 M2 code would get built and deployed. It's not going to impact other modules. That's called the microservices, making it independent. If M1 fails, do you think M2, M3, M4 would fail in microservices? There is no dependency. The code is not getting called anywhere and everywhere. It's all these models are independent. So if the issue with F1 and M1 is failing, M2, M3, M4 would not fail. Yes or no? So it gives you high availability. Do we all agree on this part, everybody? What is monolithic? What is microservices?
Yep.
Right?
Yes, sir.
Right? That's the benefit we get. It gives you high availability. I'll give you one example. So when we go to Make My Trip website, right, and we get to see other flight carriers, so many flight carriers options. We see Indigo details, Air India details, SpiceJet details. We get Go or Go Air details. We have so many flight carriers. We see options. So do you think Make My Trip owns all those flight carriers? Or do you think that Make My Trip has the database access of all those flight carriers? What do you guys think first?
No.
Then how the communication happens? Then how the communication happens?
They are accessing their APIs, API calls.
Absolutely, absolutely. So in this context, my Make My Trip is one application, independent application. Indigo is another application, indigo.com. Indigo.com has exposed APIs. So when we go to Make My Trip and give details like source, destination, date, and we click on search, at once time from Make My Trip, the API gets called of indigo.com, Air India, Go Air. They have exposed APIs. And then we get to see the flight details. So consider these two are two different independent applications. That's how the microservices communicate. So these microservices within the application also communicate using API calls. If M1 needs some information from M2, I would call the get call, post call, put call, delete call, patch call. I would call the API and get the information done. I would not call the functions. M1 could be written in Java, M2 could be written in Go, M3 could be written in Go language, M4 could be written in Python language because I'm not calling the function. Each of these modules can be developed independently of the technology because I'm calling the APIs. Do you think that Make My Trip and Indigo code base they have used the same technology? Can you say that?
Not necessarily.
No, we cannot not necessarily, right? That's what. So when we expose the APIs, it gives us a lot of options. I can develop Indigo separately, make my tip separately, or for this example, I can develop my microservices independently. And I call the APIs. So that's my second piece, microservice. Are we clear with this approach? Microservices? Everybody?
Yeah.
What it is? And the entire company, we are talking about microservices. Everybody you go, everybody would talk about API, everybody would talk about microservices. So we need to understand that. And the most important, where do we deploy these microservices? So we deploy them on containers. What is containers? What is containers? How different it is from VM? I'll show you this particular diagram. See, what happens when the software development started? We were deploying application on the physical server, some tiny little few KBs, MBs application on the physical servers. We were wasting a lot of resources. Think about, let's say this physical server is 50 core and 200 GB. And you are installing some tiny little application. You are wasting resources. Then there came the virtualization phase where we could create VMs from the same physical server. We could create multiple VMs. If you install a virtualization software on this physical server, you can create multiple VMs, right? And then once we have that, we can deploy multiple applications on each of these VMs. Now, over the years, it was found that even we are not able to utilize the capacity of a VM. So what is the next thing? Next thing is containerization. So we are taking one VM. We are installing a container engine like Docker in that, and we could create multiple containers in the same VM. It's like a process, multiple process, independent process in the same VM. And what are we going to deploy in these containers? Microservices. We are going to deploy the microservice on these containers. So containers are the like a process for a VM. In one VM, we can deploy multiple microservices. So we'll discuss Docker and Kubernetes in detail in this course. And that is where this becomes very important. And obviously, data centers, the cloud. We know all the importance of cloud, right? We cannot spend so much $1 billion in setting up data center. Easiest way to get some servers, get some storage, get some security, and deploy things in the cloud, scale on demand, pay as you use. And that's what we are targeting, all these things in the course. Now, are we feel comfortable in this particular slide? Any question on this slide technically? Before I talk about the course, anything specific on this slide?
On microservices, I have a question that you said that it is a division of multiple modules, and each modules we consider as a microservices. You suggested that like we do have a yatra.com, so only Spice or Go Air or Air India, they expose their APIs to yatra.com, and yatra.com is taking details of those exposed APIs, correct?
Yeah.
So, so yatra.com, I should consider it as a
See,
microservices.
I
And those
gave you,
exposed,
no, I think you got it wrong. You see, when I talked about the API part, when I intend to talk about how two independent applications communicate, I talked about this example, Make My Trip and Indigo. Make My Trip alone could be microservices based. See, in Make My Trip also, there are a lot of features, right? We have flights, buses, right, and hotels. We have so many other modules in that. So even within Make My Trip, I can have multiple microservices also, and those microservices would communicate in the same way using the API approach. Is what I intended to say.
okay, okay, okay. Now it's clear.
Perfect. Good. Yeah, good question. Because when I talked about that example, I wanted to focus on the API part, API communication between two independent applications, and that's how two microservices communicate with each other. Okay, good. So I'm going to move ahead with the course. So this is the course. Okay, this is what this course brings to the table. Okay, we'll talk about cloud. See, understand that everything that we discuss in this course is from scratch. From the scratch, you mean to say from literally from scratch. Okay, we'll talk about cloud, AWS, what it is. So I can go on with a lot of details about the cloud topics. Let me give you the overview of this particular course. We'll talk about Linux because see, the 95% of the deployment happens in Linux system. So we need to be comfortable with Linux. I know for sure that most of us have the exposure with Windows. We're comfortable with Windows, but not with Linux. And that's where this particular topic comes in. To get familiar, get comfortable with Linux as you are with Windows, right? Then we'll talk about the application architecture, the microservices. We'll talk about Docker. How do we create microservices? How do we create containers? How do we deploy microservices on the containers? Then we'll talk about Kubernetes, because in production, we just cannot go with Docker. We need to understand what is Kubernetes, how auto scaling works, auto healing works, auto deployment works, auto load balancing works, and all those features Kubernetes provides those features. And we'll talk about DevOps. We'll talk about DevOps, how performance engineering fits in DevOps, the CI/CD pipeline, the continuous performance testing, how a performance testers needs to be involved into CI/CD pipeline. So we'll take one example of a Jmeter job. We'll create a simple script and we'll try to integrate that with Jenkins, which is a CI tool. We'll talk about the the toil elimination, the automation perspective. We'll talk about Terraform, we'll talk about Ansible, we'll talk about observability, we talk about Prometheus Grafana monitoring tools, we talked about Elk, Elasticsearch, Logstash, and Kibana in this course, right? So, and we talk about some SRE concepts also, because a lot of performance engineers are getting exposed to SRE roles as well. So we'll talk about that as well in this course. So this is the high level what this course talks about. Okay, I'm gonna share a couple of links with you. Let me share the links. I'm gonna do. Let me. Yeah. So this particular course. So I'm gonna share this link with all of you. I'm coming up with this course, and today is the demo. Tomorrow is the day one session. And let me share this link first of all with all of you. And then we'll talk about this course. So let me share that. Okay, I have shared the link with all of you. Let me go over the course. So what are we going to discuss in this course? So whatever we are mentioning, we are going to cover. We're talking about cloud, AWS cloud. We're talking about Linux. We'll talking about ECS, Elastic Container Service. We'll talk about RDS, Relational Database Service, which is nothing but the cloud database. We'll talk about the microservices, Docker, Kubernetes, EKS, which is the Elastic Kubernetes Service, AWS, EKS, AWS Kubernetes Service, Managed Service, EKS. We'll talk about Jenkins, which is an important integration tool. We'll talk about CI/CD pipeline, and we'll demonstrate continuous performance testing in DevOps. We'll talk about Java performance engineering. What is garbage collection? What is GC, how the memory management works, how do we take a heap dump, analyze that, thread dump, GC log, we'll talk about that in this course. So this course is full packed, okay? And you can ask, there's just so many topics we are covering. How long is this course going to take? This course takes approximately 3 months, 40 hours of live sessions. We're going to meet over the weekends, 2 hours, 7:30 to 9:30 over the weekend, Saturday and Sunday. And this course goes for approximately 12 weekends, 4 hours every weekend, approximately 12 weekends, so approximately 40 hours you can consider live sessions. Again, it's not possible to cover everything in 40 hours. So what we have done, we are giving the recorded session also for few of things. For example, the Linux part, which is the easiest part. It's going to be my recorded session. We're gonna give this Linux part gonna be recorded. Everything else, all these things gonna be live sessions, and this is the recorded session. So in this, there are two recorded sessions, and those are my recordings only. Okay, you can ask any questions. So Linux and Java performance engineering is gonna be the recorded session. Okay, my recorded only. And apart from that, whatever we are discussing gonna be live sessions, 40 hours of live sessions, and approximately 13, 14 hours of recorded session is what this course offers. Okay, this course talks about. So you will have the recorded session available for lifetime. Needless to say that. Okay, for the lifetime you're gonna have. From the cloud perspective, we will. You can check my reviews and all. This page has a lot of details. The last batch, we have this demo sessions. You can go over the recordings as well. We are starting, as you can see the date, we are starting today is the demo session, and tomorrow is going to be the day one. So this course is getting started tomorrow. That's simple as that. So don't miss the session tomorrow because that's the start. And we'll talk about cloud. We'll start with the cloud. And then we'll continue from next weekend. It's going to be full-fledged sessions. You can find all the reviews that I have got, okay, in this particular link over these 4 years, right? And let me talk about the cloud computing. So we are talking about all these topics that we have here from the very basics. I don't want to go deep dive and read the what a topic name. You would get bored if you don't know. So I'm not going to do that, but these topics are so exciting once you know that. And everything is hands-on, right? All the cloud, the Linux, as I told you, it's going to be the recorded session. I'm going to show you how the recording looks, but this is going to be the recorded session, the Linux part, and these are all live sessions, software architecture, Docker, Docker file, Docker installation. I'm gonna show everything is hands-on. I'm going to show things. I'm going to execute Linux command. I'm going to show you things. How do we deploy application? How do we deploy microservices? How do you deploy multiple microservices together using Docker Compose file? Then we'll talk about Kubernetes in detail. What is pod, replica set, deployment, services, load balancing, auto scaling group, HPA, all of these things using EKS as the cluster. Will take AWS EKS and we'll demonstrate that. Then we'll talk about DevOps in this course, right? And as I promised and earlier, we'll talk about the monitoring tools as well. So Java Performance Engineering is going to be the recorded. And we are also going to cover the monitoring tools. It's not mentioned here, but Prometheus, Grafana, and Elk. Obviously, CloudWatch will covering and Linux performance monitoring. We'll cover that as well in this course. Okay, how the recorded is going to look like? Let me show you first. So this is the recorded session. Okay, look at this recorded session. One of the last thing. Okay, not the last batch, but this is the recorded one of the recorded session. We have just concluded the last batch. I can find that recording if you want. The playlist should be in the WhatsApp. This was saved, so I'm just opening that. So this is how the recorded session is going to be shared in a private YouTube playlist. Okay. This is the normal course. This is the Linux part. Going to be a couple of 4 hours, 3.5 hours of Linux, and it's going to be very basics. Okay, from cd command to chmod command. I'm going to show you how things would look like. Okay, let me show you the PPT that we share. Okay, let me show you then you will understand what are the materials you're going to get. Okay, so let me show you the cloud part. Okay, first. So this is the PPT. I just refer it for that's why I don't miss things. So all these things, as you can see, this we takes approximately 3 weekends in cloud. Okay, we spend a lot of time in the cloud, and we have approximately 160 slides, as you can see here. We talk about that. Then we talk about Linux. Okay, I'm going to share that. Hold on, where is the Linux part? Yeah, Linux. That's again. So we talk about everything here, how the directory navigation works, how the system information works, installation, how do we install things. And you can see that we start from very scratch. We talk from what is cell, and we take up things like directory navigations, man command, file operations, move command, system informations, how do you do via editor. So Linux is going to be from everything's from scratch. Okay. Docker will take about this. Uh, as you can see here, this is the Docker part, container engine. Okay, again, this is going to be approximately 40 slides. And then Kubernetes is going to be the one of the biggest, which takes approximately 2 weekends. Kubernetes in total takes 3 weekends. Uh, Kubernetes itself takes 2 weekends. Quite a lot of topics and a very important part. And we will talk about I'm going to share all those commands with you, all those things that's important. How do we create EKS cluster? How do we use kubectl commands, right? To create pods, what is pod, what is replica set, what is deployment, what is service, right? So what is HPA? We'll talk and we're going to share all those, what is node port service, cluster IP service, load balancer service, everything, right? Then we'll talk about DevOps. Now this is the Linux part. DevOps slide. Where is that? 1 second. Okay, it will be here in the DevOps slide would be here. In the SRE part, we have this DevOps slide. We're going to talk about this DevOps part. What is how DevOps works, Jenkins installations, CI/CD, traditional approach, like what is the agile approach, a sprint-wise approach, and then what DevOps brings to the table, right? And then how do we create pipeline? So we're going to demonstrate, we're going to create this pipeline. I'm going to show you the how this pipeline. So we're going to create this pipeline in the course. We'll talk about Jmeter job. We'll create this CI/CD pipeline in this course, right? I'm going to demonstrate that using Jenkins. We're going to take a EC2 instance, install Jenkins, and I'm going to create pipeline. And then on the monitoring tool, we are going to cover the Prometheus, Grafana, and Elk. Okay, we're going to do the how do we install, set up, how do we create panels, graphs, how do we monitor things, what is Prometheus, and what is Elk. We'll talk about all these things in this course as we mentioned. This is what this course talks about. Yeah. So yeah, that's all I wanted to convey in the first place. Any questions that you have, feel free to ask anybody, any questions.
Actually, I do have a question.
Go
Being
ahead.
a performance tester, that how would this course gonna help? To be very
Right.
honest, because
Perfect.
I
I totally understand. I
have
totally understand. Yeah.
covered, it
Right.
is somehow not at all related to the performance testing.
Okay. Okay. You say you think that way. Okay. Let me give you a
Yes, sir.
perspective. Yeah. Let me give you a perspective. See, performance tester. What is our role? Scripting, execution, capacity planning. Correct. Tuning.
Identify bottom application bottom.
Monitoring. Yeah.
Correct. Look at this. I just mentioned scripting, understanding requirements, scripting, execution, analysis, capacity planning. What would be the infra requirements in prod? Because based on the performance testing and tuning part, right? How do we do Java performance engineering and tuning part, right? 4 or 5 activities. Let's say you don't know AWS or you don't know Kubernetes and the entire application is deployed in Kubernetes. How would you do capacity planning? How would you know? How would you be able to suggest what would be the server configuration in prod? How
See,
should be the auto scaling configuration?
to be honest, being a performance tester, I do have 16 years of experience, but we are not the people who actually are, kind of any kind of deployment or
Not
any kind
deployment, not
of
deployment.
they,
Capacity planning. You understand capacity planning,
yeah, it's
right? See,
obviously done by the
based on
architect.
yeah, just hold on. So I have been performance testing engineering. So it depends on roles to roles that we join the company and different jobs roles that we are expected to perform. Based on the performance, what is the main role of a performance testing? Understand the production load. What would be the production load? Test the application in lower environment. Create similar kind of infrastructure as prod. Put that much load in lower environment where we don't have the risk like production, and understand the errors, the response time, the throughput, what issues that we have, and if what is the infra requirements as well. Let's say we can test with, let's say there is a prod load of, I'm giving you a number, let's say 1000 TPS. And let's say you don't have that much infra in performance environment or lower environment. Let's say you tested with 100 TPS. You could test. So you would like to know what would be the infra that is required to achieve 100 TPS, that based on your testing, and accordingly you can suggest in prod what would be the infra configuration for 1000 TPS. That's one of the important role of a performance engineer. So I'm not sure how many of you agree first. How many of have been exposed to this kind of activity?
Yeah,
But this is
agree, fine.
right. So things, if let's say if everything is deployed in Kubernetes, and let's say you don't know how Kubernetes works or microservices works, container works, how auto scaling needs to be set up, because auto scaling plays an important role. When an IPL match is going on during the streaming, the it increases, right? The streaming, the number of users increases, and the number of servers also needs to be auto scaled. So what would be the criteria of auto scaling? Based on CPU, we need to test all those things in current market trends. So if we don't know Kubernetes, if you don't know microservices, or if you don't know DevOps, cloud, if you don't have that understanding, how will you be able to do justice with that role?
Also, most of the client, when we actually when we move infrastructure from on-prem to cloud, so they do suggest it's auto scalable. Why do we even require performance testing there?
Then you're doubting performance testing. It's, see, it depends. See, what I'm here to tell you, what is the role and responsibility. See, if your client is saying not a performance testing, then you can suggest, okay, then you can confirm we will find some other company. If it's not required, then not required. Find some other better company where scalability is the concern.
Uh-huh.
Right? Where the scalability is the concern, that's where performance engineers are valued. If there is no scalability concern, the user load itself is not a concern, performance engineers will not be valued. Right? So we need to find those places where we are talking about a lot of user load, things going wrong because of load. Auto scaling is the most important thing to be tested for infrastructure optimization. Be in that space. We're talking about those spaces. We're talking about microservices, DevOps, cloud from for those perspective, for those roles here.
And I really like to know that, okay, we have developed some kind of performance test script. Okay, now when we say that we need to deploy it onto CID, CI/CD
We are
pipe,
not going to deploy. No, we are not going to deploy things. DevOps engineers are there to deploy.
so what we are going to do being a performance tester?
I just explained 4 or 5 activities. You are asking me to repeat that.
Okay, I got your point. What you just
See,
said.
if you see in your current role, if you think it's not important, so be in that thought process. I can only explain in how it's going to be important,
Don't feel
how it
offended.
has helped me.
No, and don't feel offended. I'm just trying to change my understanding.
Correct. So I have explained that part. I think
SRE perspective, because I know that SRE is very much huge in demand for sure. But I think being a performance tester is actually not required to become SRE engineer. Correct?
SRE is out of context. Forget about it. I'm not into SRE part. I'm answering your question how these 4 things are important for a performance engineer.
Okay, I might not be clear. I'll connect again later.
Sure, you can ping me. Yeah, you can ping. Okay, sure. So this is the course, what it offers, cloud part, DevOps part, microservices part, monitoring part, Java performance engineering part. That's what this course brings to the table, right? This course. So yeah,
So, so once I complete this course, right? If a company demands me to do a performance engineering, can I do that one?
see, when I say performance engineering, basically it's a part of performance testing and engineering. So first of all, you should be good at one of the tools, Jmeter. We are not taking Jmeter in this course, okay? Or Jmeter or LoadRunner. That's the performance testing. That's how you generate the load. Once you generate the load, right load, that again, to generate the right load, you need to do a lot of other activities, workload modeling, understand the prod load, right? And the architecture, and you need to understand, and then you will be able to generate the load. When you say performance engineering, we'll talk about tuning. We talk about troubleshooting, narrowing down the issue, right? So for that, we have this part, as I told, Java performance engineering. And we have this recorded session, Java performance engineering, where we talk about Java perspective, the how the memory management works, how the JVM architecture works, what is memory dump, how do we take heap dump, how do we go and take a thread dump, how do we analyze that. We have that as part of this course to troubleshoot the Java performance issues. Infrastructure issues, see, issues could be multi. As a performance engineer, first of all, you need to understand that the issue could be on the application side, which is, let's say, Java application. So that approach. Tuning is a different approach. You need to understand you need to help the developers with the code, optimizing the code, and that you can do from an analysis, GC log analysis, thread dump analysis, heap dump analysis. You can do that part. That's called the application performance engineering. From the infrastructure performance engineering, let's say you have issue with the infrastructure itself. You don't have enough infra. How much ever you tune the application, you will have the issue because you're hitting on the infra, right? So yes, you will be getting a good understanding, the very, very good thorough understanding from the infrastructure performance engineering, as well as from the Java application performance engineering. So two things we are talking about in this course. We are not taking up database SQL tuning performance engineering, but we are talking about AWS databases, which takes care of a lot of other activities, from the infrastructure perspective. You understood?
You got it, sir. Yeah.
Hi, Roshan. This is Sush.
Go ahead.
Yeah, so for this course, is there any prerequisite? I mean to say, is there any language required for that?
Nothing. No language required. See, we are talking about here in this course the infrastructure performance engineering. Okay, when I say, right, so understanding the infrastructure, what is Docker, what is container, what is Kubernetes, how things get deployed, how do we do, what is the importance, what a performance, as a performance engineer, what should be looking at. See, we are asked to optimize the pod. So if you don't understand the pod, if you don't know what is request CPU, limit CPU, or memory, or the how HPA auto scaling works, we would not be able to do the justice with the benchmarking, baselining, or the capacity planning part. So no code requirement. We'll talk about from scratch. This is the infrastructure performance engineering where we are going to talk about this using these DevOps, cloud, Linux, microservices, Docker, and Kubernetes. Yes. So no coding requirement as such.
Okay, thank you.
So any project you'll show, sir, at the last?
Yes, it will be always going to be, everything's going to be there live and the hands-on from the day one. If I talk about EC2 instance, I'll show you how do we create, how do we deploy applications, what are things to look at from the performance perspective. If I talk about the storage, let's say if I talk about S3 or EBS or EFS, I'll talk from the performance perspective. What is throughput? What is IOPS? If you have this issue in the IOPS, let's say you're observing IOPS, what you should be doing from the infrastructure perspective, we'll talk about that. So from everything, we will be doing hands-on, we'll be deploying applications, we'll be doing a complete CI/CD pipeline. Everything is hands-on, everything is, so it's not going to be the last. It's going to be on the day-to-day basis.
So, sir, another question. So, when I complete this course, I from the functional tester, what will be the my designation? Like, how can I
see? Okay, I get it. See, functional tester. First of all, are you a manual functional tester or automation tester?
manual, sir?
Manual. See, I would suggest you go on the path of automation testing. Right, first be good in your skill. This is additional skill that you will be required. Okay, I suggest this particular course to performance testers engineers. Okay, and into the operation, there was into operations. If are you trying to switch your career, then I can suggest something. But if you're trying to be in that functional testing only, I would suggest you take some Selenium course, Test NG course, Rest Assured automation course. You go on those, you be good at your skill first.
No, I just wanted to change, sir, to this.
See, this,
Yeah.
this, if you want to train, you need to learn Jmeter as well. Because this particular course can get you a cloud operations role, support role, okay, can land you the most. If you are not a performance tester, if you are a performance tester already, this course can take you to the higher level of performance engineering. You can be a senior or a lead or a staff performance engineer. You can be to that role. But if you're a functional tester trying to switch your career, so you can be a cloud support engineer using this course, with that course. And if you want to switch your career to performance, you need to learn Jmeter as well, apart from this course. Then you will be ending up as a performance tester.
Okay. Okay. Got it, sir. Okay.
Sure. Anybody else?
Yes, Roshan, one question more from my side. So suppose that if
Mhm.
the course will is completed in coming 3 months, okay, and
Yeah.
after 5, 6 months, if I got some doubt, so is there any
Yeah. See,
pipeline clarification?
let me show you. Okay, I'm gonna show you. This is my WhatsApp group. Okay, and there are so many people. Whenever the new batch completes, right? So I am always there in a group. Okay, so let's say last batch. I'm gonna find April batch or March batch. Okay, so there's a March batch. Okay, I am there in every group. I am there. So you will have my contact number to approach me. Okay.
Okay.
Okay. So I consider silence that we're all good, sorted on the questions, queries. Can I attempt AWS practitioner? We are targeting solution architect, Devi Shankar, with this course. Okay, solution architect practitioner is a very simple certification. You that we are trying to be at that level of troubleshooting. So we are targeting associate level certification with this course. Okay, 60% in 3 weekends we cannot complete the entire certification course, but 60%. If you want to clear solution architect, I can guide you what needs to be done. Additionally, I can guide you. I myself as a professional solution architect professional certified, so I can guide you what needs to be done for the associate or cloud practitioner. Devi Shankar. Okay, I see some questions in the chat. Will there be assignments as well? Yes, see, Santosh, it's going to be the hands-on session, and whatever we cover on daily basis, that will be your assignment. Okay. I'm a deployment CSD support systems engineer. I don't know how to code, but I can understand and read updates codes. Will, so this course is the perfect fit for you. Okay, if you are into support engineer, so I understand because I've been working with multiple support people because as part of L3 support, I joined the call and support engineers are always in the call. So this course is going to immensely help you. Okay, from the Linux perspective, Docker, Kubernetes, DevOps perspective, you can try to be a DevOps engineer as well in the future with this course. Well, and obviously, see, if you want to be in IT, don't say that I don't know how to code. That's fine. You don't know right now. But what about after 1 year? If you start slow, right? Learn A, B, C, D, then we can make sentences, right? So don't be scared. If you're looking for a lifetime career in IT, don't be scared of coding. Okay. Learn hello world, some prime number, start basics. You'll be able to are able to write essays after a year. Okay. So start slow, step by step. Okay. I can guide you on that as well. I get one more question, Ramesh. As of my understanding, with the session, perf testing will break the system and perf engineer will fix it. Yes. So not break the system. Our intention is to understand uh, the how the application behaves under load. That's the main role of a performance tester, Ramesh. So when we stress the system, see, think about it, right? We have match coming up in Hotstar, and if let's say Hotstar had not done performance testing and a lot of people are started to stream, what would happen? Obviously none of all the user experience would get hindered, right? Nobody would like that kind of a system, right? So that's where we try to mimic the prod load behavior using testing. Okay, that's what we try to do, and then we understand what are the issues, and the performance engineer we try to solve that issues. If the issue on the database, we solve database query. If the issue is with the infra, we solve that. If the issue is with the code, we solve that. That's what performance engineer does. Okay, at least we try to narrow down the issue. Then developers can fix that because they own the code, right? But we need to work together with the developer. Ramesh.
One more question, Roshan.
Go
So
ahead.
now my understanding has changed. So this course is not about application performance testing, but the infrastructure performance testing, kind of.
Infrastructure performance engineering, not testing, engineering, how to understand the infrastructure better so that we can suggest a better infrastructure. Okay. And this course also talks about Java performance engineering. We have the recorded session. I told you, right? I think you missed that part.
No, no, leave that Java thing. I could understand that one.
Hmm.
But from your subject or from your topics, it will be like to understand the infrastructure and how to tune that infrastructure.
Correct. How to, what is infrastructure AWS, right? Kubernetes infrastructure, right? How to
Right?
understand, yeah, right, those kind of tune that, yes.
Okay, okay.
And it's gonna be one more thing. If you're thinking the Java performance engineering is not my one, it's my recorded session. Okay. Just for the saving of time, we are doing as a recorded session. Because if I don't do that again, 3 more weekends, it will go to 4 months, the course batch. That's why we are giving the recorded session of Java performance engineering. So with this course, you'll be also able to understand how do you engineer Java applications. I hope you get that.
Yeah, yeah, yeah.
We have this, okay, in this course, 8 hours of self-paced. Okay, we are only doing that just to avoid 1 month of additional live sessions. Okay, it is there because I'm expertise in this. Okay, I have been into various roles as a performance engineer into the database tuning. We are not putting the database tuning here. Again, that would take a lot of things. So I've been into database side, multiple databases, RDS, MongoDB, Cassandra, right, Hazelcast, into Java performance engineering, where we talk about Java applications, Spring Boot applications, how do you tune that, right? By looking into the heap dump and thread dump, looking into that. So this course talks about those Java performance engineering as well.
Hey Roshan, quick question. So for these recorded sessions in Java performance testing, sorry, tuning, when would we supposed to complete that, or let's say run through it? Like where is it
See,
placed
it's
in terms
not,
of
see,
timeline?
there is no pressure from my side. It's up to your interest. I can give you on day one. And when you enroll to this course, up to you.
Right. So I wanted to understand the correlation between what we would run through in the course
We
syllabus.
will talk
Uh,
about the infrastructure. We'll talk about, so on the day one or the first 3 weekends, we'll talk about cloud. It is nowhere related to Java performance engineering, right? We'll talk from the cloud, EC2, we'll talk about storage services, EBS, S3, EFS, load balancing, auto scaling group, VPC. We'll talk about security perspective, IAM. We'll talk from the cloud perspective, 3 weekends. Finally, if you have time, you can cover that as
all right, makes sense. Thanks, Roshan.
Hi Roshan. I
Yeah,
have one doubt.
go
So,
ahead.
if I consider a scenario where we are migrating a application to cloud, so in that case, while designing a test case, we consider two aspects. One is the application performance testing and code perspective, technology perspective, and second one is what we are talking about the infrastructure.
Right.
So, like, they both test cases go hand in hand, is it? Or first we focus on the code, whether it is,
See, I'll
yeah.
tell you. I'll tell you. See, what is the eventual goal? When you migrate, everybody expects the code to behave the same, right? Or the application to behave the same. For end user, it should not matter. If I'm using Flipkart.com or Amazon.com, Flipkart goes from on-prem to cloud. It's none of I'm least interested as a user, right? I want my
Yes.
application performance to be same. So both goes hand in hand to answer your question.
Okay, okay. And in
Could
the
you
cloud
please
era,
give
we are focusing on this as because cost is a main factor, right? Like
Correct. Pay as
scalability
you
and
go.
cost
Pay as
optimization.
you go. Right. Based on the requirements. Let's say if you're using a Flipkart.com, let's say Flipkart has the maximum traffic, let's say 7 p.m. to 11 p.m. IST, let's say Indian Standard Time. So more number of servers would be scaled up only for these 4 hours, right? Then less number
Yes,
of
yes.
servers. Same thing for match. Right now, if I switch on the TV, Hotstar World Cup finals going on. So
Correct.
during this time, the infra usage on the Hotstar is much more than the regular other timings. So in Hotstar would have provisioned a lot of servers right now as compared to other time.
Right, right, got it. So, like being a performance tester or engineer after this course, I can say that I will be in the position at least where I can suggest the best configuration or okay, this
Absolutely.
configuration go for yeah, in terms of
Absolutely.
cloud.
That is,
Okay.
see, as a performance engineer, that's what we do, right? Capacity planning. We load the
Yeah, yeah,
system.
got
We load the system in lower environment and then suggest what would be the infra in prod. That's what the major role. I don't know, right? That's what I have been doing. Uh,
Yes, yes, got it, got it. Yeah, thank you, Roshan.
good.
so also would you cover the that what all kind of different scenarios would be required?
What can you could you will please be? I
The
could not
same
understand with the scenario means what.
lady which she was asking in the same thing, like if when we are moving application from on-prem to cloud, there would be two things. That one thing is application performance testing, and second thing is that we are uh, uh, suggesting the capacity of the. So
Right.
how do you do that? Do you will you cover that in that course in this course?
See, okay, to specific this migration, we don't have that, okay, but I can suggest you, I can tell you how to approach this. We are talking from the infrastructure perspective, what all to be looked at. And then from the code perspective, what all to be looked at. It's all about during the cloud migration, what all activities we can do. I have not part of this course, but I can take a one special session for that.
Okay. Okay. Thank you.
Roshan, another question. So, ideally in performance testing, let's say load testing for that matter, I would go ahead and build the scenarios, run a test in Jmeter, and then go ahead and monitor it, understand, analyze, and then start suggesting whatever needs to be done.
Right, right.
Let's say from on-prem, here what we are focusing now is the cloud. So will you also be able to, I mean, I have not gone through the course syllabus, but is this also covered where you actually do
Absolutely.
the hands-on and
Absolutely.
uh,
That's
run the
what
test
that's
and
what
then,
that's
okay,
what
okay,
absolutely that's what this course
okay.
talks about, right? Cloud infrastructure engineering. That's what this course, the entire essence of this course is that,
Right.
along
So I
with
wanted to, that's what I
Java
understood.
performance
Yeah,
engineering.
yeah.
Yes, absolutely. Absolutely.
Thanks, Roshan. Yeah.
See, every topic, cloud, Docker, Kubernetes, right? It's all be inclined towards performance because performance is my right. That's what I've been doing. It's every topic would be inclined towards that. How important, what to be looked at, how do we ensure these things, like, everything. Okay. Any other questions? World Cup match is about to start, guys. Any other questions? Finals are today.
Already started, and India is in pathetic situation.
I didn't know I was here. Okay, I need to check that. Oh, that's very sad to hear that. I was so excited about today. Okay, let's check that. Any other question, guys? Okay, so we will wind up as of now here. Please, we can meet tomorrow, 7:30, guys. Please join tomorrow, and we'll take it from the day one. Okay. Thank you so much, everybody.
Thank you, Roshan.
Thanks, Roshan.
Thanks, Rob.
Okay.